Now let's move on to 4.7. 4.7 says another circle center M with this equation. Welcome back, guys, to question 4. Now let's look at this question. It was an analytical question involving the cycle. It says here the diagram below shows a cycle with a P with center P. The equation is given as x squared plus y squared minus 6x minus 4y is equals to 12. The circle cuts the y-axis at point R, and S and RT is a tangent to the circle at point R and cuts the x-axis at point T. So we see all those points. Then we have got the angle, the theta is indicated on the diagram. So 4.1 said determine the coordinates of P as well as the radius of the cycle. All right, let's have a look at this one here now. Let's see. Okay, we go to our equation here, guys. 4.1. What we're given is x squared plus y squared minus 6x minus 4y. It's equal to 12. So what you do when you're given something like this, we group all the x's together. X2 minus 6x plus y squared minus 4y. As you can see, guys, you remember from grade 10, what is missing here, we're missing the last term here, and we're also missing another term here. So in order for us to find those terms, what do? We complete the square. So how do we complete the square? We complete the square by saying x squared minus 2x. You divide the last term here. You divide this term by 2, and then you edit this on the next one. So if you divide here by 2, what you're gonna have? You're gonna have negative 3. Then you square it. Okay. So similar thing applies here. Y squared minus 4. You divide this by 2 and then you square it. So it's going to be plus negative 2 all squared. However, what you do on the left, you must do on the right. So what did we, how much did we add here? We added 3 squared, which is equals to 9. And then this side we added 2 squared, which is equals to 4. So basically what you just did now on the left, you also did on the right. So basically, if you were to move back on the equation, you realize that you actually didn't do anything. All right, therefore what do we do after this? We take what is outside the bracket, minus 3. Okay, minus 3 all squared. You take what is outside the bracket, you take x without the square, then you take the last term without the square. Same thing applies here with y. It's going to be plus here. You take y without the square, then you take this without the square as well, therefore all squared. Therefore you add what is on this side. Now you will get 25. So the coordinates of P, we know it should be 3 is to 2, and therefore our radius, by looking at this, our radius, it is going to be 5. All right. If you've got any questions, guys, please let me know on the comment section below on this one. Moving right along, let's move on to 4.2. Show that the coordinates of R, so we already have these ones here, which is 3 is to 2. So now they said show that the coordinates of R are 0 is to 6. So from the original equation that is given to us, what we can do, let's go to it now. We know that here is when x is equals to 0. So R is sitting here at the y-intercept. So it means definitely this side x is equals to 0. So we just have to look for y. So let's come to our original equation. The reason I'm using the original equation here, guys, is that just in case if at 4.1 I made a mistake, therefore I don't get the second question wrong as well. So now we know that x is equal to 0 here. Okay, let's go ahead and substitute x is 0. And then let's see. Right, there you go. So we're going to be left with y squared minus 4y minus 12. I've already taken 12 from the other side. The only thing that we need to do now is to factorize the trinomial y. Two numbers is going to be 6 and 2, negative 6 plus 2. Y is equals to negative 2, or y is equals to 6. So it's definitely not negative 2, because negative 2 is somewhere here. What we're looking for, y must be positive. Therefore, the coordinates of r will be 0 is to 6. Right. There you go. So that's how you would deal with that one, ladies and gentlemen. Let's move on to 4.3. All right, next question, 4.3. If you still remember the coordinates here, it was 3 is to 2, and therefore 0 is to 6. And then the radius is 5. All right, I said 4.3. 4.3 says here, 4.3. It says here, determine the equation of a tangent RT. So which is this line here. Okay, so we know that this line, because it's a tangent, is perpendicular to that. So if we can find the gradient of RP, therefore we should be able to find the perpendicular gradient thereof. All right. So therefore gradient of RP is going to be given by y2 minus y1. Some will say yp, y minus, it doesn't matter, guys, as long as we substitute correctly. Is going to be 6 minus 2 all over 0 minus 3. Therefore, our answer for the gradient of RP is equals to 4 is going to be equals to 4 over negative 3. So therefore, the perpendicular gradient of that is going to be just the reciprocal of that, which is the gradient of RT, is going to be given by 3 over 4. Therefore, we need to go and find the equation gradient x minus 1. I'm using the equation here to find, so then I'm going to use this point here that is on the line. Therefore, y is equals to negative 6, 3 over 4, x minus 0. Therefore, our equation of RT of the tangent is going to be 3 over 4 x plus 6. Great stuff. And that's how you would deal with this one here. That's the equation of RT 4.4. Guys, as you can see on this on these questions like this one, if you stick to the basics rather, and then you don't rush yourself, I don't see you making a mistake. But if you rush, you are most likely to make a mistake and you will forget some of the, in this question like this one, there's no trick whatsoever. You just have to follow the basics. All right. If you practice and do as many examples as possible, I don't see you struggling. But however, if you are, please let me know on the comment section below and we'll see how can we assist. All right. 4.4 is to determine the size of theta round off to 1 decimal. All right. You know the relationship between the gradient and it says that gradient is equals to tan theta. So this is the gradient of line RT. We know the gradient of line RT is 3 over 4. So therefore, there is tangent theta there. So now we just have to go into our calculator, look for that reference angle, say second function, shift 3 over 4. And then this would give us an angle of, I think it's 36.86 degrees. This is our reference angle, guys. Please don't make a mistake. The reason is a reference angle. Let's have a look at this angle is sitting on this quadrant here, and therefore on this quadrant, what do we have? We have got 90 plus theta. All right, so therefore theta is going to be equals to 90 plus 36.86. But guys, even if you can see, let's say maybe you don't understand where is this 90 coming from. This is coming from trigonometry. But guys, I mean, if you look at this, né? If you look at this angle is like 30 something. 30 something is the angle here. This is 90, okay? So 36 is this side here. 36 is this side before 90, because this is 0, 90, therefore 180. If you just analyze it from simple trigonometry. So now, I mean, it's on this second quadrant. So now you need to add something so that it becomes over this, because 36 will just be on the first quadrant. I hope you guys understand that. Okay. So 4.5 said a vertical line is drawn as a tangent to point P, where A at Q, where A is greater than 0. So X value is greater than 0. So this line is drawn as a tangent to point P. Okay, so there's a line that is drawn here. Determine the coordinates. So there's a tangent that is drawn here, guys, like that. So I think that this line is sitting somewhere there. Then there's point Q there as a tangent here. So it means here, right here already. Oh, I'm going to need a different color. Apologies for that, guys. It means here now already here. What you have here, you have got what? You have got an wait a minute, I don't think this is correct. I don't think I'm doing this right. It's the other way around rather. Okay guys, let me have a look at this one again. It says here the line is drawn as a tangent, okay, with the center P. Okay. Oh, all right. Actually, I'm right. I can see. Okay, yeah, I'm fine. I think I'm all right, guys. Here, Q is here. It means now the Y value would remain the same. The X value is the one that is going to change if we were to draw a tangent there. Okay, guys. So now at 4.5, this is what you would do. You already know the Y value. What you're looking for is the X value. So you are gonna go to your original equation and substitute to find the X value if Y is equal to 2. Okay, let me see. If you were to do that, plus Y squared minus 6x x2 negative 4y is equals to 12. So therefore, if you are looking for X, if your Y is equals to 2, you're gonna look for X here if your Y is equal to 2. There you go, x squared minus 6x. Here what you're gonna have 4 minus 8, you're going to have minus 4. Then we bring 12 from the other side is equals to 0. Bring x to the other side is equals to 0. So now therefore is going to be x squared negative 6 x minus 8 16, it's equal to 0. Okay, so you factorize here, guys. Equals to 0. X we are looking for two numbers, negative 8 plus 2. x is equals to -2 or x is equals to 8. -2 we already have, so therefore we would know that the coordinates of q, therefore the coordinates of q, they are going to be equals to 8 is to 2. Right, let me know what you think, guys. Let me know what you think. If you're not getting it, please let me know. Okay, let's move right along, moving to 4.6. all right, 4.6 says that for which values of k will y be a second to the second. All right, so in this case, guys, what you are looking for, what the basically asking you is the point of contact between the two tangents, even though they didn't say it directly here, but that's what they are looking for in this case. So what you would do in this case, let me just put there, I've got 0 is to 6. Okay, what you would do in this case, guys, you are going to look for them. A midpoint is the midpoint between what and what. Okay, let me see here. Oh yes, you are looking for this point here, guys. Okay, so let's say there's a point here that you are looking for, x and y, and this one is already your midpoint. So now what you are looking for here is this point of contact between the tangent and the circle, because never the tangent that we have drawn was passing somewhere here. So now this is what you would do. You have got this point here, and then this one becomes your midpoint. All right, so what you can do here, you're going to use the midpoint formula using it in reverse. This is your midpoint, so you are looking for that x. So 3 is the midpoint. Therefore, what are you looking for? X1 is 0 plus x2, which is just x over 2. All right, same thing would apply with y here. Okay, but let's solve for this one first. Is going to be 6 is equals to x. Therefore, the same thing applies with y. What do you have? Your y would be 2. It's equals to 6 plus y divided by 2, which will give you 4 minus 6. You guys are already in grade 12, so that's why I'm skipping some of the steps. Y it's equals to -2. See, guys, so therefore your coordinates here at this point, let's rather just call it point M, they would be equal to 6 is to -2. And then therefore what you do, you look for this equation now of this tangent here at this particular point here, M. So now when you look for that equation, going to be y minus 2 is equal to, you already know the gradient, that's the same as the gradient of the original tangent before, minus x1, which is my -6. All right, so if you were to simplify this, 3 over 4 is x, and therefore when you multiply throughout and you remove the bracket thereof, you should end up with -13 all over 2. All right, skipping some of the steps here, guys, for the length of this video so that it doesn't take too long while you are viewing it. So now what you have now, you have got two tangents. The other one was with this 3 over 4x plus 0 plus 6. Okay, then this is the next one here. (13/4). So now for which values of k? For the values of k that where k is greater than this one here, the smaller one, greater than -13/4, but k also less than 6. Yes, less than 6. All right, and that's how you deal with this question, guys. If you don't understand, please guys, leave a comment on the comment section below. I will do my best to assist you thereof. All right, now let's move on to 4.7. 4.7 says another circle center M with this equation, where the only thing that change here is the radius with a different center is drawn. Will the circle touch or cut circle P, or will it either touch nor cut circle P? Show all your calculations to determine your answer. All right, this one, guys, if you have a look at this one, 4.7, this one, it was a little bit difficult for me while I was working it out alone. The center here is -3, -2. Okay, so what you do here, guys, I think you must use the distance formula. Yes, you must use the distance formula between the two circles, between this circle and this one. What is the other one? Oh yeah, 3 and 2. So find the distance between these two, guys. I'm not gonna do it here. Use the distance formula. I want to see you guys engaging with me on the comment section below to say this is what you got. Then I will make a separate video only to explain this question. So I'm gonna leave this one for you guys. Use the distance formula, find the distance, and therefore compare the distance between the two circles, or between the two radius, if they will cut each other. Please let me know what you get, guys, but I'm just gonna give you an answer. For me, this is what I got while I was working it out alone. I got 2 square root of 13. So please let me know. And then the answer that I got is that this circle will cut circle P twice. All right. Okay, guys, please let me know what you think. It was only worth 4 marks on this question, but I think if you've done the distance formula and you get it right, you would have gotten 2 marks thereof. Okay, I am Gaston Mapala. Let me see you on the next upload, where we'll be doing question 5.